Hey everyone, it's You'll Be Blessed here, making it clear, making it plain, opening up the heavens for my teaching is like rain. And today I'm here to give you the keys to understanding the periodic trends. And I'm going to give you a very clear and organized overview of how all the periodic trends function and work, or most of them at least. All right. So you're going to be able to define the periodic trends so that you can discuss the role of the subatomic particles on chemical properties of atoms. And the key here is you've got to understand the interactions between the particles, specifically the subatomic particles, because they're the ones that exhibit the patterns. So let's go. The first thing is the driving forces behind periodic trends. There are two of them, all right? They drive home many of the trends, 95%. I'm just throwing out a random number, but the majority of all the periodic trends are caused by two driving forces. The first one is called the effective nuclear charge, and this is actually the attraction of electrons to the nucleus due to the addition of protons, okay? So that means as we are adding protons to the nucleus, there's a stronger attraction of the electrons to the nucleus. And this primarily works as you describe trends that go across the period. So from left to right, okay? And the thing is, we're always talking about horizontal trends, okay? And as long as you're comparing elements on the periodic table that are in the same period from left to right, then we're always going to be referring to the effective nuclear charge as the reason for that trend happening, okay? Next is electron shielding, okay? And the electron shielding has to do with the repulsion of the valence electrons due to the addition of energy levels, okay? So we got one energy level, two energy level, three energy levels, four. So when we're adding electron shielding, we're actually forcing the valence electrons to actually escape or even get pushed further out, all right? And so this is primarily a trend that you see going down the periodic table, down each group. It affects all of the trends on a vertical perspective, okay? And as long as you're comparing elements that are on different periods, okay, different periods of the periodic table, then you can actually attribute the periodic trend to electron shielding. Electron shielding primarily induces the all the different chemical properties, specifically the periodic trends, okay? So let's look at two periodic trends that I think have something in common. All right, the first one is the ionization energy, and I'm just going to make it very clear right here. I just want to compare and contrast the two, and keep it moving. All right, so ionization energy is the energy absorbed for removing electrons. Well, ionization energy has a cousin, or her name is electron affinity. All right, and so electron affinity is the opposite of ionization energy, and it is the energy released upon receiving an electron. So you got ionization energy which is absorbed from trying to remove an electron, and then you got the electron affinity, which is the energy released upon receiving. All right, I hope you like that hand motion going on there. And so the focus of these two, I put these two together because whenever you're talking about the periodic trends, these two specifically focus on one atom, one atom, one atom. Okay, just like that. All right, one atom. Okay, so you're never going to talk about ionization energies and electron affinities when you're talking about multiple atoms, only a single one. All right, and so let's move on to the next. So the next set of periodic trends is actually based on a different focus, and you might even be able to predict what this focus is, but let's dive in. The first one is electronegativity, which is the attraction of bonded electron pairs. So now we're actually pairing up electrons, okay? Next, when we move on to the atomic radius, we're now talking about half the distance between nuclei based on electron pairs again, all right? So you might already be seeing the theme if you are really astute. And then the final periodic trend that I decided to throw in with this batch is the melting and boiling points, which is based on, again, paired or even unpaired electrons. And those paired and unpaired electrons actually determine the phase transitions. And phase transitions is really just the fancy general term for melting and boiling, evaporating, all that stuff, but specifically focusing on melting and boiling points. All right. So why did I put these together again? Well, simple. The focus is actually not just on one atom, but two. And so when you're dealing with electronegativity, you're always going to speak with regards to two atoms within a compound, And these two atoms can either be the same or they can be completely different. All right. But then when you're talking about the atomic radius, you must be talking about one type of atom, one element. Same thing with melting and boiling points. You must be talking about one atom and one boiling point, because when you begin to talk about those in respect to mixing different atoms together, you actually have to change the vocabulary. So atomic radius, two identical neighboring atoms, and melting boiling points, the same thing. All right, so that's it. I've just given you the keys to understanding the periodic trends, beginning with the two driving forces, effective nuclear charge and electron shielding, that are responsible for causing or influencing many of these periodic trends. Then I gave you the two periodic trends that focus specifically on a single atom, which is ionization energy and electron affinity. And then finally, electronegativity, atomic radius, melting, and boiling points. All three of those actually focus on two atoms being combined and the sharing of electrons, or the distribution of electrons. So I hope this gave you a very quick and simplistic overview. I hope I made it clear, I made it plain, so that your life can be blessed by this video. And make sure you check out any of my other videos on the periodic trends. Have a blessed day. This is You'll Be Blessed, and I'm out.